question is, what is the value of log base 10 1 and a half, log base 10 1 by 3, log base 10 1 by 4 up to 198 terms. Okay, so let us just simplify the fractions first. The fraction can be easily simplified. So the first thing is log base 10 1 by 2 can be written as 2 1 ja 2 plus 1 is 3, so it can be written as 3 by 2 plus again the log base is still the same, base 10. The next number is 3 1 ja 3 plus 1 4 by 3 plus log base 10 is again the same. Now the number is 4 1 ja 4 plus 1 5 by 4. So we should write 5 by 4 for the next one, and this will keep on continuing till the 198 term. That's what they're asking for. So we have to find out the 198 term also. So 198 term will be what? Log base 10 200 by 199. That should be the 198 term. As you can see, the first term has got 3 and 2. So the first term has got second in the denominator and 3 in the numerator. Second term had got 3 in the denominator and 4 in the numerator. So in the same pattern, we can see the 198 term will have 198 term should have the next number, that is 199 in the denominator, and the very next number, that is 200 in the numerator. So this is what is the complete pattern. Okay, now we can see that there are the base of the log is always common. Log base 10, log base 10 is always common. So we can combine those numbers by using a property. That property is log base of anything. Let's say 10 only. M into n is nothing but log base 10 m plus log base 10 n. This is what is the property. This is how we can expand the product term into the plus terms. Okay, so this is what can be used here. So if as the product term can be expanded in the plus term, separated by the plus term, similar way the plus term, the separated plus term can be joined back as the product term. So that's what we're going to do. We're going to join back these separated terms. So if you join back them, so there will be a single log base 10 now, and all these fractions will be get multiplied to each other. So if you do like that, we're going to get 3 by 2 as the first one, multiplied by 4 by 3, multiplied by 5 by 4, and then this will continue to move, and then the second last term would have been 199 by 198, and obviously the last term would have been 200 by 199. This is how it will be. And if you see this pattern, there will be numbers that will get cut. For example, this 3 and 3 will get cut, this 4 and this 4 will get cut, this 5 will get cut with the next 5, and then so on. It will keep on cutting in the same way fashion. This 199 is going to get cut with this denominator's 199. So ultimately only two numbers would have been left out. This is the one denominator 2 and the numerator 200, because they will not get cut. So ultimately you will be left out with log base 10 200 by 2. Okay, log base 10 200 by 2 is nothing but log base 10 100. Okay, this is what is log base 10 100. Now how we can write log base 10 100 is, log base 10 100 can be written as log base 10 10 square. This is how the log base 10 100 can be written as. Now we can use one more property. What is that property? Log m to the power n is written as n log m. Log m to the power is written as n log m. So we're going to use this property here. Okay, here we have got the power as 2. So this can be written as 10. This 2 will come back here. So it can be written as 2 log base 10 10. And we have one more property that can be used here. What property is that? Whenever the base and the expression, base and the number are same, like that, log base m, this is always 1. So here we have got the same connection. The same connection is we are getting the 10 and 10 as same. So obviously the inner part, log base 10 10 will be just 1. So we're going to get 2 into 1. That is nothing but 2. And that should be the right answer. 2 should be the final answer available in option number B. Becomes the right answer for us. Now, log base 10 2 is equal to 0.3010. Log base 10 2 is equal to 0.3010. Now the question is log base 10 2 is equal to 0.3010. Then find the value of log base 10 5. So clearly the log of 2 has been given to us, and we are supposed to find out the log of 5. So obviously we need to manipulate this 5 in terms of log of 2. Okay, and if I can manipulate this number 5 in terms of 2, then only I can find this particular thing. Otherwise log base 10 5 has a definite value that cannot be directly found out. Okay, So let us try to manipulate this 2 in terms of 5. So we have been given log base 10 2 as 0.3010, and we are supposed to find out the value of log base 10 5. So this log base 10 5 can be written as, in place of 5, we can write 10 by 2. Okay, why we are doing that? So that we can convert this particular 5 into some form of 2. Now, if you see this, if we do further manipulation, this can be written as log base 10 l- log base 10 10 minus log base 10 2. How I can write it like that? Because there is a property. What is that property? Log of m over n, log of m over n over any base is actually equal to log m minus log n. Okay, log of m over n is always log m minus log n. So using the same thing, we applied it here. Log base 10, log base 10 10 over 2 is nothing but log 10 minus log 2. This is what we have applied. Now the log 10 value, log 10 over 10 value is always 1 minus log base 10 2. So log 2 value has been given in the question itself, that is 0.3010. If we use this, we have to write it down here, 0.3010, and 1 minus 0.3010, if we solve, it comes out to be 0.6990. So that should be the right answer. 0.6990, which is available in option number B, becomes the right answer for us. Let's see the next question. The positive solution of the equation log base x plus 3 x square plus 6x plus 9 plus log base 5x plus 2 6x square minus 6x is equal to log base 2x minus 1 8x cube minus 12x square plus 6x minus 1. This is what is the equation given. We are supposed to solve this. So solving means we are supposed to find out the value of x. So let us see this, what we can do about it. Okay, let us see the left hand side first. Log base of x plus 3, and what we can write in place of x square plus 6x plus 9 is, see, x square plus 6x plus 9 is nothing but x plus 3's whole square. We can expand it in rough also. X plus 3 whole square is nothing but a square, that is x square, plus b square, that is 3 square, plus 2 into 2ab, so 2 into x into 3, that ultimately becomes x square plus 9 plus 6x only. So in short, x square plus 6x plus 9 can be written as x plus 3's whole square, plus the second part is log of base 5x plus 2, and the next term is 6x square minus 6x is equal to log base of 2x minus 1. The base is 2x minus 1. And if we see the rightmost part, that is 8x cube minus 12x square plus 6x minus 1, this is nothing but log 2x minus 1's whole cube. Because if we expand 2x minus 1 whole cube in the form of a minus b whole cube, okay, so we can get the value. A minus b whole cube is nothing but a cube plus a cube minus b cube minus 3ab, a minus b. So if we expand it like that, so we can easily see the values of that. So it is going to be a cube, that is 2x whole cube, minus b cube, that is 1 cube, minus 3ab, so it's going to be minus 3 into 2x into 1 a minus b, and a minus b is always 2x minus 1. If we solve this further, we're going to get back to the same value as this. So clearly this expanded form of 2x minus 1 whole cube can be just written in the short form as 2x minus 1 whole cube. This much has been done. Now, if you see the left hand side, x plus 3 and x plus 3. So what can be done here is, this particular x plus 3 can be, there's a power over that. There's a power of x plus 3's whole square over there. Now we can use a property. That property is log of m to the power n can be rewritten as n log m. Log m to the power n can be rewritten as n log m. So using this, what we can do in place of this, we can bring down the 2 at the back, 2 log base x plus 3, and then it will be x plus 3 again. Okay, because this 2 would have dropped back, and this can be further written as, see, base of x plus 3 and then again x plus 3. Whenever you see something like that, log base mm, there's a property called as log base mm is always 1. So in place of this 2 log base x plus 3, what we can write down here is 2 into 1, that is nothing but 2. So this particular first term has got a value as just simply 2. Okay, now see the last term, the right hand side term. The right hand side term is this. We can again find out here. See, you can again use the property of log m to the power n is n log m. Using this property, this 3 can be brought back. So it can be written as, this particular term can be written as 3 log base is 2x minus 1, and in the bracket again 2x minus 1. 2x minus 1 again in the brackets. Okay. Now, this 2x minus 1 and 2x minus 1 can be again operated in the same way as the earlier one, log base m and m. So this is always equal to 3 into 1, that is nothing but 3. So this right hand side term has become 3. So what is the final value that we have reached to? The leftmost value has become 2, and then the second value has become, second value is as it is, log base 5x plus 2, 6x square minus 6x. So it's going to be log base 5x plus 2, and inside the bracket is 6x square minus 6x, is going to be, the right side had become 3 as we made it. So side had become 3. So it's coming like that. Now if we solve this further, so this can be brought as log base 5x plus 2, and the expression is 6x square minus 6x is 3 minus 2, that is 1. Okay, 3 minus 2, that is 1. See, uh, now there can be one more property used here. What is that property? Log of base A, B is equal to C. If the things are connected in this way in the log form, in the mathematical form they are connected as A to the power C is equal to B. In the mathematical form they are connected as A to the power C is equal to B. That is, A to the power C is equal to B. So if you see this math form, so this math form can be applied here also. If A log base A and B equal to C is A to power C equal to B. So this whole expression can be written as 5x plus 2 to the power 1 is equal to 6x square minus 6x. Like that, 5x plus 2 to the power 1 is equal to 6x square minus 6x. So clearly we have an equation now. What is that equation? 6x square minus 6x is equal to 5x plus 2. So we can create an equation out of that. If we create it, it becomes 6x square minus 11x minus 2 is equal to 0. If we solve this equation, then we can factorize the things. Okay, if we factorize the thing, the ultimate factors that are coming are 6x plus 1, then there is x minus 2 equal to 0. If we solve this further, this is coming out to be first factor x equal to minus 1 upon 6, and the another factor is coming as x equal to 2. So these are the two values of x that are coming. What he had asked in the question, let us see the question again. He had asked in the question the positive solution. Okay, so we have got two solution. One is minus 1 by 6, another one is 2. So obviously the positive solution is 2 itself. So that should be the right answer only, available in option number A, x equal to 2. Next, the number log base 27 is, okay, the number log base 27 is an integer, a rational or irrational number, or a prime number. So this is what we need to check. So let us assume this as a rational number first. Okay, if you assume it as a rational number, let us say let it is a, let log base to 7 is rational number. Okay, let us assume it is a rational number. So what is the definition of a rational number? A rational number is a number which can be expressed as in the form of p by q, where p and q should belong to natural numbers. Okay, p and q should be both the natural number. If your particular log base to 7 or any particular number is can be expressed as p by q, and p and q are both the natural numbers, so this is how the things can be related. Now, so if the log base to 7, log base to 7 is written as p by q, so we need to convert this further. So obviously we have a property which was used in the last question also, which said if the things are connected this way in the log form, their mathematical form is a to the power c equal to b. A to the power c equal to b. So the similar math form if we use here, then we can get 2 to the power p by q is equal to 7. This is what we get as the mathematical form. Now 2 to the power p by q is equal to 7. If we raise the power of q, okay, if we rise the power of q on both the side, left hand side and right hand side as well, so rise the power of q, so it's going to be 2 p by q, and there's a power rise in q, and similarly 7 to the power q, we can do it like that. So if you do this q and q gets cut on both the sides. So on the left hand side you remain with 2 to the power p is equal to 7 to the power q on the right hand side. This is what you get. But this particular expression is not going to be possible, because the reason behind that is left hand side of the this particular equation is always even, because every power of 2 falls in the even number. But if you see the right hand side is going to be odd, because 7 raised to any power is always coming in the even in the odd form. So even number cannot be equal to odd number. So obviously our assumption that we assumed in the first statement, that let the log base to 7 is rational, is wrong, is false. That means this particular number is not a rational number, rather it is an irrational number. Okay, rather it is an irrational number. Our assumption was wrong. Now let us explore the other part of it. The other part of it was whether the particular number is integer or not. Now this number cannot be integer also, because log base to 7 number is never integer. It has to be falling in some decimal numbers. Okay, that cannot be broken down, so it is always a decimal number, and decimal numbers are never integers. Okay, decimal numbers are never integers. Okay, so that's why it cannot be integer as well. So if it cannot be integer, so obviously it cannot be a prime number. Okay, because the prime numbers are only the integers numbers only. Okay, but it is not coming as an integer, so it cannot be a prime number also. So these three factors are completely false. That is, it is not an integer, it is not a rational number, it is neither a prime number. So what is the right answer that remains is option C, that it is a irrational number, and is the right answer. Now, question number 5. If log base 47 is equal to x, then log base 716 is equal to what? Okay, this is what we have to do. He has given us log base 47 is equal to x, and we are supposed to find out log base 716's value. Okay, so here, if you see it carefully, that this particular log base 716 we have to find out, we can use a property here. This log base 716 can be written as log base 7 4 square. Okay, if you do this, then we can use a property. That property is log m to the power n is always n log m. If you use this property, this 2 can come back here, and it should become like 2 log base 7 4. 2 log base 7 4. Now we have we have to find out log base 7 4 value, 2 log base 7 4 value, and we have already have log base 4 7 value. See, the numbers and the number and the base are interchangeable. So if we have some property who can change the base and number of our thing given already to us, then we can obviously will be in a state to find out the value of log base 716 also. So, do we have a property? Yes, we have a property. The property says log base mn can be manipulated to become like log base nm. That is, base and number can be swapped if you completely take the multiplicative inverse. So let us use this property. So if log base 47 is equal to x, then let us manipulate this. So this can be manipulated as 2 log base 74 can be manipulated as 2 over log base 47. Okay, 2 over log base 47. See, the base and number have been interchanged using this property itself. Okay, and log base 47 we have already got, the value is x, so obviously it's becoming like 2 by x. So that is going to be the right answer. The right answer is 2 by x, available in option number A, and becomes the right answer for us. Next, value of log 0 is always so this is a constant value. Log 0 is always going to be undefined. Okay, this is a constant. Log 0 is never defined. Okay, so we can call it as not defined. Okay, or we can also call it as undefined. This value is particularly not defined, so the right answer is option number D, undefined. Okay, let's have the question number 7. Find the value of log base c cube a cube into b cube. That's what has been given to us. Okay, so let us find out something. Okay, so we can remove these powers in some way. How we can remove the power? Log base m n n to the power a. If things are like that and the power is over the number, then this power can be dragged back, and it can be written as a log base m n. Similarly, if this particular power is over the base, for example, this power is m to the power b and then n. So the power is over the base, not over the number. So this can be written as 1 by b log base m n. So whenever a base has got a power, that power completely goes back in the divide form. And if the number has got a power like that, like this a comes back in the multiply form. If both the things have got power, then obviously let us have one more example combining together. Suppose the base was m, it had got a power of b. The number was n, it had got power of a. If the things were like this, then this can be written as a by b log base mn. See, the numbers power has come back in the multiply point situation, and this base power has come back in the divide situation. So this has to be ultimate expression. Now let us use this particular property in the question given to us. Okay, they ask it for log c cube to the power a cube b cube. Okay, let us just rewrite this. If you rewrite this, this can be written as log c cube a into b's whole cube. This can be written like this. Now, obviously, both the numbers have got power, so we're going to use this particular property as discussed earlier. So, this 3 can be brought back here, and the base power can be brought back here again. So, it can be written as 3 by 3 log base c a b. Okay, then 3 and 3 gets cancelled. So, we are left out with log base c AB. Now we can use one more property, that log mn is equal to nothing but log m plus log n. So if we use this property, we're going to get the solution of this. So it can be written as, this particular expression can be now written as log base c as it is, a plus log base c b. It can be written like this. Okay. Now before that, we can do one more thing. Now one more property can be used. The property says log base AB can be written as log of B over log of A. It can be written like that also. So let us use this property for both the terms that we have. Okay, if you use this, then this particular term can be written as log of A over log of C. Another can be written as log of B over log of C. Things can be written like that. So clearly we can add them. If we add them together, so the denominator is always log C, and on the numerator part you have log A plus log B. Okay, now on the numerator part you have log a plus log b over log c. So that should be the ultimate answer, log a plus log b over log c. Let us find out which particular option is containing this answer. It is contained by option number B, so that is the right answer. Now they say if log 2 is equal to 0.3010 and log 3 is equal to 0.4771, then find out the value of log 48. Okay, in this kind of situation, we can factorize 48, and we can break the 48's factor into 2 and 3 form only, and then we can use the log form. Okay, so let us try to break 48 first. If you do the prime factorization of 48, you can get the factors. It can be cut by 2 again, 2 12 ja, can be 2 again, 2 6 ja, it can be cut by 2 again, 2 3 ja, so it can be 3 1. So 48 can be written as 2 to the power 1 2 3 and 4 to the power 4 into 3 to the power 1. This is how the 48 can be written as. So clearly we're going to write this 48 as, okay, so we're going to write this 48 as log of 48. In place of log of 48, we're going to write log of 2 to the power 4 into 3 to the power 1. Now, if you use the property of log mn is equal to log m plus log n, if you use this particular property, then this can be again broken down into log of 2 to the power 4 plus log of 3. Okay, this log of 2 to the power 4 can be written as 4 log 2, as we already know that log m to the power n is n log m. Okay, so using this, we can write it like this. Okay, plus the another number is just log 3. Okay, if we solve this, log 2, what is the log 2 value? Log 2 value is already given in the question, 0.3010. So we can write it like 4 into 0.3010, plus log 3 value is also given in the equation, that is 0.4771. Okay, so these are the value that we get. Now we are simply supposed to apply the BOD mass and know the answer. If you apply this, 4 into 0.3010, 0.4771, the final value comes out to be 1.6811. So that is the final answer which is available in option number B, and is the right answer for us. Now, a solution of log base 10 x plus 20 log base 10 100 is equal to 5. So we are supposed to find out the solution of this particular expression. So we can do it like this. So let us once write it, log base 10 x plus 20 plus log base 10 100 is equal to 5. That is the expression given to us. Okay, so clearly we can combine this, because there's a property called as log base of any number m plus log base of any number n can be combined as log base 10 mn. Can be combined like that. So if we use this property, we can combine it like here also, log base 10 and these two things can be combined together in the multiply form. So it's going to be 100 into x plus 20 is equal to 5. Okay, it can be written as 100 into x plus 20 is going to be 5. That is what is the thing given to us. Now what we can do is, there is one more property which says we can separate them again, that these two terms are in multiply, we could have separated them also, but we can do one more thing, that log base 10 100 can be solved easily. Okay, log base 10 100 can be solved easily. How come? Log base 10 100 can be written as log base 10 10 square, which is nothing but 2 log base 10 10, and 2 log base 10 always log 10 10. When the base and number are same, it becomes 1, so it is going to be 2 into 1 only. So in place of log base 10 100, we can just write 2. So that's what we're going to do. We're gonna not going to expand them, rather we're going to just use the value. So if we just use the value after this expression, we're going to get log base 10 x plus 20 as it is, plus the log 100 value is 2 is equal to 5. Okay, if you solve this further in this easy way, then you can see what can happen down. Log base 10 as it is, x plus 20 is going to be 5 minus 2 is 3. This is what the thing becomes. Okay, now if you solve this further clearly, now there is one more property which says log a b equal to c are connected mathematical form as a to the power c equal to b. Using this here, we can get 10 to the power 3 is equal to x plus 20. This is what we get. Okay, so clearly x plus 20 is coming out to be 1000, and which gives us x value as 980. So that is going to be the right answer. The solution of x is nothing but 980. Let us see which option is having it. It is contained in option number B, so that's going to be the right answer. Okay, let us have question number 10. Log base 2 root 2 to the power to the number is 512 is going to be what? So let us just write it first. Log base 2 root 2 and the number is 512 is going to be what? That's what we are supposed to find out. See, log 2 root 2 can be written as log 2 into 2 to the power 1 by 2, and this 512 can be written as 2 to the power 9. 512 is nothing but log 2 to the power 9. Now we have a property which says, let us combine the property first, the values first, the power first. It's going to be log base 2 to the power 3 by 2 into 2 to the power 9. It's going to be like that. Okay, now we know that there is going to be another, let us say, the property. The property is, if the base has got a power m and the number has got a power n, so this can be written as base has got a power also and the number has got a power also. This m will go back in divide and this n will come back in multiply, so it can be written as n over m log base ab. Using this here exactly, we can get the final expression as log base 2 2, and this 9 would have come back in the multiplicate part and this 3 by 2 would have come back in the divide part. So it converts into this particular form. Okay, see, log base 2 2 is always going to be 1. Whenever the base and number are same, it's always going to be 1. So ultimately we are getting the final answer as 9 by 3 by 2. That is nothing but the final value is 6, and it is available in option number C becomes the right answer. Okay, log base xy is equal to 100 and log base 2x equal to 10, then find the value of y. That is what we are supposed to solve. Okay, let us find out. So clearly the first thing that has been given as log base 2x is equal to 10. Okay, using this we can find out the value of x clearly. Okay, log base 2x is equal to 10 has been given to us, so we can try to find out the value of x using a property which says log base ab is equal to c. So the mathematical form is a to the power c equal to b. So if we use this particular connection, we can get mathematical form is 2 to the power 10 is going to be x. So clearly x is going to be 2 to the power 10 or 1024. Okay, now if we use this particular x value in the other form, in the other expression, what will happen? Okay, let us just put it. If we put it like that, the expression is log base x y is equal to 100. That is the ultimate expression. If we replace x by the value called as 2 to the power 10, what's going to happen? Okay, let us just see, and we can compare this particular property can be another time explained by this. So here also x to the power 100 is becoming y. So the one more thing that is coming with us is x to the power 100 is going to be y, using the same property we have done with it. Okay, now here we can replace this x as 2 to the power 10. If you do that, this is going to be 2 to the power 10 to the power 100 is equal to y. Okay, so y values comes out to be 2 to the power 1000, as clear as possible. So that is the right answer. Y value is 2 to the power 1000. It is available in option number B, and is the right answer for us. Now, log base 10 3 is equal to 0.477. The number of digits in 3 to the power 50 is. Okay, this is a different kind of a question, but we can easily solve this. Okay, what we can do. Okay, the thing that is given to us is log base 10 3 is equal to 0.477. Okay, let us first assume x is equal to, what is, we are supposed to find out the number of digits in 3 to the power 50. So let us assume x equal to 3 to the power 50. Okay, now take the log on both side. If you take the log on both side, what is going to be on the left hand side? It's going to be log x. On the right hand side, it is going to be log of 3 to the power 50. Okay, and using a property that log m to the power n is equal to n log m, using this property, this particular expression can be further written as log base x is going to be 50 log 3. Okay, now log 3 value is already given in the question itself. In the earlier in the topmost part, log 3 value is already given to us, that is 0.477. Let us replace it like that. So log x is going to be 50 into 0.477. Okay, if I multiply this, 50 into 0.477 is ultimately coming out to be 23.850. 23.850. So the number of digits going to be, okay, number of digits going to be, just use this particular number. Whatever is the number before the decimal part is there, just use this number. So the number of digits it is going to be this 23 number plus 1, that is going to be 24. Okay, so whatever is number coming before the decimal part, you need to just add 1 to that number, and whatever the final number comes out after that, after adding 1, that is going to be the right answer. So the number of digits as asked in the question are nothing but 24. So that is going to be the right answer available in option number B. Okay. Log 2 is equal to x, log 3 is equal to y, and log 7 is equal to z. Then find the value of log 4 into cube root of 63. That is what we are supposed to find out. Okay. So let us just simplify log 4 into cube root of 63 first. The log 4 multiplied by cube root of 63, that is what has been given. Okay, this can be written as log 4 plus log cube root of 63 can be written as 1 by 3 log 63. How we have written like that? Because log of 63's cube root is nothing but log of 63 to the power 1 by 3, and we have a property which says log m to the power n is n log m. So this 1 by 3 has been dropped out back. So that was had happened here. 1 by 3 has come back, and 1 by 3 log 63 is the final expression. Now, this is what we have right now. Now, what we can do about it? Now, we can break down 63 also. So, if we break down 63, this is going to be log 4 as it is plus 1 by 3. This log 6, this 63 can be broken down as 3 square into 7. That is 9 into 7 is 63. So, we have written 3 square for that. Okay. Now, let us do it further. Log 4 can also be broken down. Log 2 square plus the next part is 1 by 3, and this can be written as log 3 square can be written as 2 log 3, and log m into n is always log m plus log n. So we can break it like log 1 by 3 into 2 log 3 plus 1 by 3 again into log 7. Okay, 1 by 3 into log 7. But what property has been used here? The property called as log m n is equal to log m plus log n. This particular property has been used up here. Okay, so this can be written as 2 log 2 plus 2 by 3 log 3 plus 1 by 3 log 7. This is how it can be broken down as. Now, we have been given the value of log 2, log 3, and log 7. So that's what has been done in this particular question. We had manipulated, we have simplified this particular expression in the form of ultimately log 2, log 3, and log 7 only, so that we can reuse and we can put the value of log 2, log 3, and log 7 as given in the question itself. So let us put these values x, y, and z respectively for log 2, log 3, and log 7. If you do like that, this is going to be 2x, this is going to be 2 by 3y, plus the next one is going to be 1 by 3z. Okay, 2x plus 2 by 3y plus 1 by 3z. This should be the final answer of our question. Let us see where it is available. It is available in the option called as It is available in the option called as A and is going to be the right answer for us. Okay. Now let's go to the next one. Okay, so we have a question where 2 log base 16 minus x square plus x minus log base 4 x plus 1 equal to 2. So here you can see the bases of both the logs are different. One has got a base of 16, another one has got a base of 4. So there is a property of log that then two logs term or multiple log terms can only be operated together when the bases of their logs are same. Okay, so here the bases are different, so we'll have to make the bases same. Okay, so either we have to make 16 in terms of 4 or 4 in terms of 16. So both are easy. So let us try the first part. So we're going to make the 16 in terms of 4. So we can write 16 in terms of 4 as 4 square. And then there is x square plus x minus log of base 4 x plus 1 is equal to 2. That's what is given to us. Now for operating this, we have got a property. For operating this, we have got a property. What is that? If you have got a power over the base, if the base is m and it is got a small power n, and then there is a simple number a, so this base's power goes back and divide. Like 1 upon n, this becomes 1 upon n log base m a. So the base's power always goes back and divide. So we can use the same situation here. So base's power is 2. So this 2 will go back and divide. So we will have 2 by 2 then log base 4, and then we'll be left out with x square plus x minus log base 4 x plus 1 is as it is equal to 2. Now this 2 and 2 gets cancelled. Now we have the basis of both the logs as same. So now you can combine them together using a property. What is the property? Log m minus log n is nothing but log m by n. So we're going to use this property. If we do that, we are left out with log base 4 x square plus x divided by x plus 1, n is equal to 2. Okay, now here in the numerator side x can be taken common. So if we do that, we are left out with x then x plus 1 inside divided by x plus 1 already present. Base is always 4 is equal to 2. If we do like this, then x plus 1 and x plus 1 gets cancelled. So what are we left out with? We are left out with log base 4 x is equal to 2. And this particular equation can be solved using a property. That property says when you have three things connected in the log form like this, then their mathematical connection is a to the power c is equal to b. It's like that. A to the power c is equal to b. So if we use this mathematical connection, then 4 to the power 2 should be x. So clearly x value is 4 to the power 2, that is 4 squared, that is nothing but 16. So that is the final answer. X value is coming out to be 16, which is available in option number B also, and becomes the right answer for us. Okay. Next is log base 3 value is given out to be 0.4771. Then find the number of digits in 3 to the power 100. Okay. For this, there can be a thing. Let us assume, first of all, we do what? We assume let x is equal to 3 to the power 100. Let x is equal to 3 to the power 100, because we have to find out the number of digits in 3 to the power 100. So any mathematical way is difficult to find to give you the number of digits, and 3 to the power 100 is going to be a very huge number. So it's conventionally it is not possible. So we have to use some trick. What is that trick? So let us assume x equal to 3 to the power 100. Let's take log on both the sides. Okay, if you take log on both sides, what will happen? Log x is equal to log of 3 to the power 100. Now on the right hand side, you can use a property. On the left hand side, it is as it is. It is 100 log 3. And which property we have used? The property that is used is log m to the power n is nothing but n log m. That's what we have used. Okay. Now log x becomes 100 log 3. Now, now you have a log 3 value, and log 3 value can be replaced from the questions as it is given. So if you replace that, you're going to get log x is equal to 100 into, and log 3 value is given out to be 0.4771. Okay, if you multiply it together, so it comes out to be 477.1. So ultimately we are left out with log of x is equal to 477.1. This is what we are left out with, rather 47.71, not 477.1, it's rather 47.71. 47.71. Okay, now this particular expression can be again dealt with. See, log x is equal to 47.71. Now this value, the log x has come out to be 47.71. So what do we do next with it is we ignore the numbers that is after the decimal. We ignore the numbers that are after the decimal. We rather take the numbers that are just before the decimal. That the number is 47, And if we do plus 1 to it, if we do plus 1 to this 47, we're going to get 48. So the number of digits in 3 to the power 100 are nothing but going to be 48. Okay, it is that simple. Whatever is the number that is on the left hand side of the decimal number, we add plus 1 to it always, and whatever number we achieve after that, that is going to be the number of digits in the ultimate expression, that was 3 to the power 100. So number of digits in 3 to the power 100 are nothing but option B, 48. Okay, let's take on the next question. Log base 10 5, log base 10 5x plus 1, log base 10 x plus 5 plus 1. Okay, this is what we have to solve. So clearly, when we have things in the same log basis, that they can be operated together. So let us take on the left hand side first. In the left hand side, we have log base 10 5 plus log base 10 5x plus 1. Okay, so the base of the logs are same, so we can use a property which can combine them. The property will be written after that. 5 into 5x plus 1, this will it become. Okay, what is the property that has been used here? The property is log m plus log n is nothing but log mn. So this is the property that has been used. That's why the two terms have come in product form. So this is what is the left hand side. Okay, so it is 5 into 5x plus 1. Let us see the right hand side. What is happening in the right hand side is, the right hand side, there is already a log base 10x plus 5, and if we convert this plus 1 into any log form also, then both the terms can be combined together and combinedly operated. So how can we convert 1 in the log form? Is simply by simply writing log 10 10. Okay, we can simply write log 10 10, that will be the conversion of 1, because base and number, if the base and number of any log are same, that gives you a value 1. So clearly 1 in the base of log can be written as log 10 10. So we can clearly like this, write this as log base 10 10. Okay, now the bases have become just same, so we can operate them together as used by using the similar property as used in the earlier statement. So it will become like log base 10 x plus 5 into 10. Okay, that is your right hand side. So now we can equate left hand side and right hand side together. Okay, we can equate the left hand side and right hand side together. If we do that, what do we get is, the right hand side was 5 into 5x plus 1, and right hand side is 10 into x plus 5. So we are just supposed to solve this particular equation. So 5 can cut 10 by 2, so we are left out with 5x plus 1 is equal to 2x plus 10, which gives us 3x is equal to 9, which gives us x value as 3. So that is how we have solved the equation. That's what they were asking for. What is the value of x? So it is going to be option called as B. 3 is the right answer. Now, log a minus b is equal to log a by b, then b is equal to what? Okay, so let us just try to compare this. Log a minus b is equal to log of a by b. So clearly log of a minus b is equal to log of a by b. So we can use a property. So if both the log have got the same base, so they can be equated also. So a minus b is clearly equal to a by b. Okay, now we are supposed to find out the connection between them. So let us try to they're supposed to find out b. So we'll solve for b's value. So what we can do, we can try to separate b from it. Okay, so how we can do that? A minus b is going to be a by b, so which will give us b value is simply going to be a by a minus b. There can be multiple ways in which we can solve them. Okay, if we take the denominator and the numerator up, then we can find out clearly b is coming out to be 1 minus a by b. Okay, b is clearly coming out to be 1 minus a by b. Okay, so that's what should be the value of b, that is 1 minus a by b. And where it is available, it is available in option number D, and becomes the right answer for us. Okay, let us just see question number 18. What is that is happening? Log of base 179, 179 by root 32,041 is equal to what? 32,041 is equal to what? So let us try to manipulate the number. So this is the expression with us. Let us try to manipulate this. The base is 179 only, and on the numerator part is 179, and then there is under root of 32,041. So if you try to find out the under root of 32,041, 30,041, you can do this by prime factorization also. And if we find out the under root of 32,041, that is nothing but equal to 179 only. Okay, so clearly under root of 32,041 can be written as 179. Okay, so let us write 179 here also. Okay, so if you solve this 179 and 179 gets cancelled, so you are left out with log of base 179 into, and the number is 1, and log of 1 to any base is always 0. Okay, that is the property. Log of 1 to any base is just 0. So clearly the right answer becomes simply 0, which is available in option number and becomes the right answer for us. Now, find the value of 7 log 1 plus 3 log 2 plus 4 log 3 minus 2 log 6. So this is what we are supposed to solve. Okay, let us just try to do it. Okay, what we can do, see the basis of log, all the logs are same, so they can be operated together. So what we can write down, see we have a property log of m to the power n is equal to n log m. So this property can be used in the reverse way also. When you have n log m, then can be written as log m to the power n also. That's what we'll do with the first part of it, and the second part of, and third and fourth, for every part we'll do the same thing. So the first term was 7 log 1, which can be written as log 1 to the power 7, taking the power ahead, plus the next term is 3 log 2, which can be written as log 2 to the power 3, taking the power ahead, plus similarly we can write log 3 to the power 4 and minus log 6 to the power 2. This is how we can write it. All the log terms can be now combined, so this we can write them, rather we solve them first. Log 1 plus log, this is nothing but log 8, plus this is nothing but log of 3 to the power 4 is going to be 81, minus this is going to be log of 36. Okay, now we can combine them all together. See, all the log plus terms can be combined in the multiply, and the minus term can be combined in the divide form. So let us combine the multiply term. So it is going to be log of 1 into 81 into 8 divided by 36. How we have done that? Because there's a property log m plus log n is always equal to log n, m into n. And one more property is log m by n is nothing but log m minus log n. So whichever terms were connected in the form of subtraction sign, they have come in the divide form, and those who are connected in the plus form have converted into multiply form. Okay, if we solve this further, what does this give us? So we can cut these numbers. This is 9 4 ja 36, and this is 9 9 ja 81. Okay, 4 can cut 8 by 2, so it's coming out to be log of 18. That is coming out to be the final answer, and this cannot be further solved also. So that should be the right answer only, which is available in option number B. Log of 18 is the right answer. Now, what says the next question? Log base 3x plus 2 log base 9x plus 3 log base 27x equal to 12. Then find the value of x. So in this particular question, as you can see that particularly basis of each log is different. Okay, basis of every log is different, so they cannot be operated together unless and until we manipulate the bases and make them equal. Okay, how we can do that? Let us try to do it. Okay, the first thing that is given is log base 3x, then the thing is given is log base 9x. So let us try to do it. So we cannot do anything about log base 3x. There is nothing to manipulate. If we see the next term, see, so obviously m log n can be written as log n to the power m. This m can go further over the n. So using this, we can write 2 log base 9x as log base 9x square. This is how we can write it. Okay, then then the next term can also be written as log base 27x cube. This is how the things can be written as. Now let us try it further. Log base 3x, this is as it is. Now there is one more property where we can raise the power of the base as well. What is written is log base 9x square. This can be written as log base 3 square. Okay, and x square, 3 square and x square. And base and number both have got the power. Whenever this situation happens, what happens is, suppose the base is m, the power is n of it, then the number is a and the power of it is b. So this particular expression becomes what? This particular expression ultimately becomes b by n. B goes back in multiply, n comes back in divide, b by n log base ma, b by n log base ma. Using this, both the numbers have got the power of 2, so this ultimately will become 2 by 2 log base 3x. Okay, the first numerator 2 will be the power of the number, and the denominator 2 will be the power of the base, plus the next term will become what? 27 will be 3 cube. Okay, log 27 will be, this will be nothing but log 3 cube x cube, which will ultimately come out to be 3 by 3 log base 3 x. So that's what we'll write here, 3 by 3 log base 3 x. Okay, now these 2 by 2 and 3 by 3 gets cancelled, so what are we left out with? Log base 3 x plus log base 3x plus log base 3x. This is what we are left out with. And on the right hand side, they have given it to be 12. So let us not try to solve further. So this is nothing but 3 times of log base 3x is equal to 12, which gives us log base 3x is equal to 12 by 3 is 4. Now we can use a property which says what? Log of base a b equal to c. In the mathematical form, it can be written as a to the power c equal to b. So let us use the mathematical form. So 3 to the power 4 is equal to x, which gives us x value as 3 to the power 4 is nothing but 81. So that should be the right answer. X value should be 81. Option number A becomes the right answer. Okay, let's go for the next one. Which one among the following has a stronger base? Okay, which one of the following has got the stronger base? Let us just judge it. Okay, the stronger base will be that one in which the base value is very high. The first value is zero point 0.3. Next base is 0.01. Okay, next base is 0.01. Another base is 0.1, and the last base is 2. Okay, these are the bases. So whichever number will be bigger out of them will have the stronger one. Okay, so the most big number, the biggest number is 2. So clearly the option containing the base as 2 will be the right answer, which is available in option number D. So this is the right answer, which has got the stronger base. Okay, the next is find the value of log under root 2809 minus log 53. So we are supposed to solve this. So first of all, let us try to find out under root of 2809. And if you try to solve this using factorization, you can get the number is simply 53. Okay, under root of 2809 is nothing but 53. Okay, root of 9 is nothing but 53. So we can replace this under root of 2809 as 53. If we do this, this is becoming log of 53 minus log of 53. Log of 53 minus log of 53 is nothing but 0. So that is the right answer, option A, which says it is 0. Okay, next question. Log of xy square over z cube is equal to log x plus 2 log y minus a. So we have to typically solve for a. So let us try to do it. Okay, this is what is the expression given to us. Let us try to solve this. Log of xy square over z cube is equal to log of x plus 2 log of y minus a. We have to solve this expression for a. Okay, so we can simply expand this. Okay, how we can expand this? See, we can use multiple properties. Log m into n is equal to log mn, log m plus log n. Okay, log m plus log n. Okay, so in this way we can separate x into y square as log x plus log y square, and there is a term in the denominator also. For that we can understand it like log m by n is always log m minus log n. So whatever term is in the denominator has to come in the subtraction form. So in the denominator we have a term called as z cube, so that should come in the minus sign, minus of log z cube. Okay, is equal to, on the left hand side, on the right hand side I have log x plus 2 log y minus a. Okay, let's go further. Now let us try to simplify it further. There is log x plus log y square can be written as 2 log y. The property that has been used is log m to the power n is always n log m. That is the property used. Minus, similarly, log z cube can also be written as 3 log z. The same property being used is equal to, on the right hand side I have log x plus 2 log y minus a. Okay, now if we see left hand side and right hand side, we can cut few things. Okay, this log x and log x get cancelled, but it is available on the both the sides. 2 log y and 2 log y gets cancelled. So ultimately we are left out with a is equal to 3 log z. That's what we have left out with. A is equal to 3 log z, and that should be the final answer only, which is available in option number C and becomes the right answer. Now 1 upon log xy base xyz log base yz xyz and log base zx xyz is equal to what? Okay, so we have a similar problem here. The basis of each log is different. So that is what is the limitation of log. You cannot operate two logs together unless the basis of the logs are same. Okay, if we don't have the basis of the log as same, we try to manipulate them and make it like that. So for that we have to have some property. What is the property? That there's a property which says log of base AB can be written as 1 upon log base be a. That is, the base and number can be interchanged. Okay, so in every of these term, if the base and number are interchanged, then base of every term will become xyz, xyz, and xyz, and then this particular expression will be able to solve this expression. So for base interchanging the base and the number, we have to use this particular property, which will interchange the base and number between us. But the problem is it have to go in the multiplicative inverse sign. So, okay, so let us try to see this. What will happen with the first one? So if you take the multiplicative inverse, this will become 1 upon 1 over log. The base and number will be interchanged, so it will become xyz, xy. Base and number have interchanged, and the whole expression has gone in 1 upon, which is nothing but simply log xyz, xy. Okay, log xyz, xy. So this will be the first term. First term will become like this. Similarly, the next term will also become like log of xyz, and the next term has got yz, so yz will come up. And similarly, the third term will become like log of xyz, and the third term had zx as the base, so that will come up as zx. So this is what we'll achieve after this. Now in this situation, we can use our property which says log m plus log n is nothing but log mn. That is, they come in product form when they are combined. So all the three terms can be combined together in the product form with the same base called as xyz. So the things will be combined like xy into yz into zx, which will be nothing but log of base xyz into xyz's whole square. Okay, will be xyz's whole square. Now this thing can be operated as 2 of log base xyz, xyz. Okay, we have used a property log of m to the power n is nothing but n log m. This is what is the property that we has been used here. Now base and number are same. Whenever the base and number are same, it becomes 1. So it is equal to 2 into 1. Why so? Because whenever you have a base and number as same, it always give you a value of 1. So it is nothing but 2 into 1, which is 2. So that should be the answer of this question, which is available in option number C, and it becomes the right answer, that is 2. Okay. Now we have log base 10, 3 value is 0.477. The number of digits in 3 to power 40 is. We have done this type of question as well earlier. So what do we do in this such type of question is, so we have to find out the number of digits from 3 to the power 40. So first of all, we assume let x is equal to 3 to the power 40. This is the first thing that we do. Now we take the log on both sides. If we take the log on both sides, what we are we left out with? Log x is equal to log of 3 to the power 40. So simply log x can be written as 40 log 3 using a property. What is the property? Log of m to the power n is n log m. So we have used this property here. Now log x become 40 log 3, and we know the value of log 3. It is already given in the question, that is 0.477. So simply log x is coming out to be 40 into 0.477. Okay, if you multiply 40 and 0.477 together, it gives you 19.08. And what do we do in this kind of situation is, we take the number what is just on the left hand side of decimal. The right hand side number is completely discarded. The left hand side number is taken. The left hand side number is 19. So the number of digits is, number of digits in 3 to the power 40 is going to be 19 plus 1. Okay, that is nothing but 20. So that should be the right answer. 20 should be the number of digits available in the question, asked in the question, that is 3 to the power 40. So the right answer is option number C, 20. Now this is the next question. What says, find the value of log base 2, log base 3, log base 4, log base 4 to 56. So we can solve this one by one. Okay, how we can solve that? We can start solving it from 256. See, 256 is nothing but 2 to the 4 to the power 4 to the power 4. 256 is nothing but 4 to the power 4. Why we have broken down in the power of 4? We could have broken down 256 in the power of 2 as well, because the base of the question is 4. Base of the expression at the very last is 4. So that's why we have broken down 256 in the power of 4, so that when the base and number will become same, we'll make them 1 using a property. So what is the first step that can be done is log base 2 written as it is, then log base 3 written as it is, then log base 4 written as it is. Then inside what you do, log base 4, and for 256 you can write 4 to the power 4. So this is what it becomes like this. Okay, now let us keep writing from left hand side, log base 2 as it is, log base 3 as it is, then this log base 4 as it is. Then what has happened here? 4 to the power 4. This is the expression. So let us do it here. Log base 4, 4 to the power 4. So 4 to the power 4 can be operated as, this 4 will go on the back side. So it will be 4 log base 4, 4. What property has been used? Log m to the power n is n log m. So this power has come back. It's 4 log base 4. And whenever the base and number are same, that is 4 and 4, the whole log becomes 1. So it comes out to be 4 into 1. That is nothing but 4. So in place of this small brackets, we can just write 4 and can close all the brackets, rest of the brackets. Now this is the next next expression that we have. Now we have to keep solving for this. Now if you see this 4 and 4 are again becoming same. This 4 and 4 are again becoming same. So that will just become 1. So what will be left out with? Log base 2, then log base 3, then there are middle bracket, and then there is just a 1. Okay, because log base 4 and 4 will just give you answer as 1. Okay, now we am left out with this. Now there is a log of 1 being taken. Log of 1 to any base is always 0. So the expression should become log of base 2 and inside should be 0. Log of base 2 and inside should be 0. That should be the final answer. And log of 0 is undefined. Okay, log of 0 is not defined, is undefined. So basically we are taking the log of 0 on any base is undefined. So that should be the answer only. Option number D should be the right answer, which says it is undefined. Now, the next question is log base 12 27 is equal to A. Then the value of log base 6 16. That's what we are supposed to find out. So let us write the expression first. Log base 12 27 is equal to A. That's what has been given to us. Now, here we can use a property which says log base B A can be written as log A over log B. It can be written like that. So if we use this property, so left hand side can be written as log of 27 divided by log of 12 is equal to A. This is how we can write the left hand side. Now, what can be done further? Now, this 27 can be written as 3 cube. So we can write log 27 as log 3 cube divided by log 12 can be manipulated to write log 2 square into 3, because 12 is nothing but 4 into 3, which is 2 square into 3. So we manipulated this expression to become like this, to look like this. Now we can use certain property in this. On the numerator, what we can write? 3 log 3. What property is being used? Log m to the power n is n log m. In the denominator, we can write log 2 square plus log 3. Okay, and the log 2 square will be nothing but 2 log 2 using the same property. So it's becoming like 2 log 2 plus log 3, because log m into n is log mn. So that's why the plus separate sign has been come out from the multiply sign. So this is what is the step that you got. 2 log 3 log 3 over 2 log 2 plus log 3, and that is all always equal to A. Okay, 2 log 2, 3 log 3 over 2 log 2. So if we now let us take the multiplicative inverse of this. Why we are taking the multiplicative inverse? So that we can cut few things. Log 3 and log 3 can be cancelled together. So if we take the multiplicative inverse, the expression looks like 2 log 2 plus log 3 upon 3 log 3 is equal to 1 over A. Now, if you separate them together, how it should become like 2 log 2 over 3 log 3 plus log 3 over log 3 is equal to 1 by A. This is what it remains. Okay. And this log 3 and log 3 gets cancelled out with each other. So what are we left out with just? We are left out with 2 log 2 over 3 log 3 is equal to 1 by A. 2 log 2 over 3 log 3 is equal to 1 by A. Okay, and log 3 and log 3, and there was this 3 log 3 also. So log 3 over 3 log 3. So 1 by A minus 1 upon 3, because there was a 1 upon 3 left out here. So that has to go on the right hand side with subtraction sign. So it become like this. If you solve this further, what does it become? Okay, 2 log 2 over 3 log 3 is equal to 1 upon A, which can be written as, taking the 3A as common, can be written as 3 minus A. So it's going to be 3 minus A over 3A. Now, here where what we can do, 2 log 2 over 3 log 3 has come out to be 3 minus A over 3A. Now, we can give both of them 1 log. So what we are left out with? We are left out with log 3 is equal to 2A upon 3 minus a log 2. Okay, through a upon 3 minus a log 2. This we have achieved by multiplying together and cross multiplication thing. This is what we have achieved. So you can cross multiply and you can see the same thing can be achieved. Now if you go further, now we are supposed to find out log base 616. We are supposed to find out log base 616. Okay, what we can write log base 616 as log 2 to the power 4, because that is what is 16, and log 2 into 3, because that is what is 6, 2 into 3. Okay, the same property has been used. Log base a b can be written as log b over a. So log base 616 has been written as log 16 over log 6. That 16 has been written as 2 to the power 4, and that 6 has been written as 2 into 3. Now the same property can be used. Log m to the power n is nothing but log n log m, so it's 4 log 2 divided by log 2 into 3 can be again written as log 2 plus log 3, can be written as log 2 plus log 3. So it's become like this, 4 log 2 over log 2 plus log 3. Now the value of log 3 can be replaced what we have achieved in this particular expression. Okay, we can replace the log 3 value as per this expression. If we do that, what we can get out of it, so it's going to be 4, and the log 2 value is still there. Okay, so it's going to be 4 log 2 divided by the first log 2 is as it is, plus the log 3 can be replaced by 2a divided by 3 minus a log 2. Okay, this is how it can be replaced as. Now obviously the log 2 can be taken common and can get cut, so I am left out with just 4 into 3 minus a over 3 plus a. I'm just left out with 4 into 3 minus a over 3 plus a, and that should be the right answer only of the whole expression, where it is available 4 into 3 minus a over 3 plus a is available in option number D. So that is our right answer of this question. Okay, solve. We have to solve the expression that is coming out to be there. Log 2 square over 3 plus log 2 to power 4 over 3 square plus log 2 power 6 over 3 cube plus so on till log 2 to power n over 3 to power n. See, clearly we can see that the base of each log is same, so they can be operated together. There should be no problem in operating them together. So if we do it like this, what we can see here, see, we have a clear property that log m plus log n is always equal to log mn. So how many, as many multiplicative terms are there, as many product terms are there, and as many plus terms are there, they will be combined together in the multiplicative form with a single log. Okay, so here we have multiple log and they are separated by plus, so they can become a single log with the product sign involved. So if we do like this, so we're gonna have the whole thing can be combined as log of, okay, product of all of them can be combined as log of product of all of them, that is 2 square divided by 3 into 2 to the power 4 divided by 3 square into 2 to the power 6 divided by 3 cube, and this will continue in multiplication as 2 to the power n divided by 3 to the power n. This will keep on continuing like this and all the logs will be combined. So if you clearly notice the pattern, what's happening here is the powers are 2 squared, then 2 to the power 4, then they all are getting multiplied. Okay, so the last power would have been what? The last power would have been, there will be a pattern in the last power. Every power is just the product of that particular power and the power ahead of it. So ultimately you will achieve in the numerator side is what? Log of 2 to the power n into n plus 1. Okay, to find out any particular term, what we can do, so that will have to multiply it by log that particular term and the next term ahead of it. For example, if you want to know the first term, it is 2 square. How we can achieve 2 square? By putting n equal to 1 in this expression, we'll achieve 2 square. If you want to know the second term, what we'll have to do, we'll have to put n equal to 2. If you put n equal to 2, then what it will become 2 into 3, that is going to be 3 to just 6. So that's what will be the next term. So this is how the pattern is looking like. So divided by, if you see in the denominator, what's happening, 3 into 3 square into 3 cube, and then it's so and so it is going on. So this is nothing but a GP itself. So what we can write for this is simply the product of the GP is going on there. So it's going to be n into n plus 1 by 2. We can also understand this as sum of n natural numbers. That's what is happening because the power get added up. Whenever the multiple things are in product form, the powers get added up. So if the powers get added up, you get the series. Okay, so one series available in the GP form in the denominator, that is 1 3 to the power 1 into 3 to the power 2 into 3 to the power 3, they all are combined, so there should be a power of 3 to power 1 plus 2 plus 3 plus 4 till n, which is nothing but making a AP. Okay, and the sum of n natural number can also be treated as like that, so that is nothing but n into n plus 1 by 2. That's what has been used in the denominator. And what has been done in the numerator part is, that is 2 square, 2 to power 4, 2 to power 6. So clearly the powers are getting the numbers are getting multiplied, so the powers are getting added up. So it's like 2 plus 4 plus 6 plus 8 till n. So this is nothing but making a AP, and the sum of that AP is coming out to be n into n plus 1. So this is what is the final expression that we have: log of 2 to power n into n plus 1 over 3 to the power n into n plus 1 by 2. Where all it is available with us, it is available in option called as A itself. So that should be the right answer only, option called as A. Okay, let us see the next question. Log base ax equal to 2 and log base bx equal to 3, then find the value of log a by bx. That's what we are supposed to find out. Okay, we are supposed to find out what? We are supposed to find out log a by bx. This is what we are supposed to get. Now, how we can use this? We have a simple property which says log base mn can be written as log of n over log of m. This is how it can be written as. So log base a by b x can be written as log of x divided by log of a by b. It can be written like that. Log of x divided by log of a by b. This is the first step that has been done, which can be further written as, now, the bases are not given to us, so we can assign any base to them. Okay, the bases are not given to us, so we can assign any base to them, and the assigned base should be common in the numerator and denominator both. So if we do like that, so the numerator, let us assign the base as x to both, so it will be log base x x, and on the denominator will be log base x a by b. And let us try to break this a by b using the property log m by n is log m minus log n. So if we break this, the numerator remains as it is, base x x, and on the denominator we can break down this as log x a minus log x b. This is how it can be broken down as. Okay, now if we further solve this, log base x x, so obviously this log base x x will be equal to 1. Why so? Because we have a property, whenever the base and number are same, so it will always be equal to, mathematically equal to 1. Here the base and number are same, so it is mathematically equal to 1. So what we achieve, 1 divided by log base x a minus log base x b. Okay, 1 divided by log base x a minus log base x b. This is what we achieve finally. Now, what have been given to us, the things that has been given to us is log base ax and log base bx. And what do we are achieving? Log base xa. So clearly there is a base and number interchange issue. So if we are able to interchange the base and number of the expression here and here, so clearly we are in a state of replacing the values, the numerical values. So we have a property for replacing. What is that property? The property says log of base ab is equal to 1 upon log base ba. So we'll have to do the multiplicative inverse. If we do the multiplicative inverse, the base and number get interchanged. So if we do like that, what we achieve out of this, 1 over log base ax minus 1 over log base bx. This is how we can write this as. The multiplicative inverse has been done. If we are doing multiplicative inverse, clearly the base and number are interchanged. Why we have done that? Because we have got the value in the question of log base ax and log base bx as well. So now let us replace these values in the numerical form. So what do we achieve out of this is going to be 1 over 1 upon 2 minus 1 upon 3. So clearly I need to solve this particular mathematical number now. So it's going to be 1 over 3 minus 2 over 6. That is nothing but 6. So that is the final answer. The right answer becomes 6, available in option number A, and becomes the right answer for us. Now, the next question is log base 10, 7 is equal to A, then find the value of log base 10, 1 over 70. Okay, so what we have to find out? We have to find out the log base 10, 1 over 70. This particular value has to be found out. So clearly we can use some property into it. That's what is the strategy also. When we are not getting the clear indication how to solve this, then whatever is the unknown expression, we'll try to simplify that using whatever property that we know about it. Okay, the first property that I can use here is the property called as log m by n is simply going to be log m minus log n. So this property can be used out here. If we do that, we can convert this into log base 10 1 minus log base 10 70. Okay, clearly it can be broken down like that. Now, one log of 1 to any base is always 0. So clearly it is 0. 1's log is always 0. So it is or completely 0. Minus log base 10 70. Now this log base 10 70 can be written as 7 into 10. Okay. Now we can use one more property which says what? Whenever the terms are in the product form, like log m into n is nothing but log m plus log n. You know that clearly. Whenever the log terms are in the product form, they can be separated by giving plus sign in between. So clearly we can write this as minus of log base 10 7 minus of log base 10 10. Okay, minus of log base 10 7 and minus of log base 10 10. Now my log base 10 10, that is log of 10 is nothing but again going to be 1. So clearly what we do, we get minus of log base 10 7 minus 1. Okay, and log base 10 7 is value is already given in the expression. Log base 10 7 is given as what? A. So we can clearly replace that in our expression, log base 10 7 value as A. So which will give us minus of A minus of 1 minus of A minus of 1. This is what we will get. Okay, minus of A minus of 1. Now if we take the minus sign common, we're going to reach out to minus of A plus 1. So that should be our final answer, minus of A plus 1, which is available in option number A and is the right answer for us. Now the question says log base A AB is equal to x, then value of log base B AB is what? Okay, this is what we have to do in this side type of situation when the clear indication is not present or the clear property cannot find the answer, then we are supposed to manipulate whatever has been given to us. Okay, we should try to always apply the basic properties in whatever things has been given to us. The thing that has been given to us is log base A AB is equal to x. Okay, let us try to use the very basic properties in that. So clearly this can be separated by log base A plus log base A B. The property that has been used is simply log mn is equal to log m plus log n. This is what is the property that has been clearly used. Log mn is equal to log m plus log n. They have been separated by the sign of plus and is always equal to x. Now if you see it here, log base AA, this is always equal to 1. Whenever the base and number are same, the expression is 1. So this part is 1. The second term is log base AB and it is equal to x. So clearly we can find out log base AB is equal to nothing but x minus 1. This is what is log base A. B's value is there. Log base AB is equal to x minus 1. Now what we are supposed to find out? We are supposed to find out log base BAB. So clearly the base of this thing should be base B. But what we are finding out here is base A. So we need to transform this base into B. How we can transform that? We can have a property. What is that property? Which can change the base and number and interchange the base and number in between. See, log base mn can be swapped as 1 upon log base nm. Okay, so the multiplicative inverse if you take, then you can obviously interchange the base and the number. So let us apply this to this situation. So it can be written as 1 over log base ba is equal to x minus 1. So which further gives us what? Which further gives us log base ba is equal to 1 over x minus 1. Okay, log base ba is equal to 1 over x minus 1. Now we are not supposed to find out log base ba, we are supposed to find out log base b AB. So let us try to start manipulating that. Okay. For that, what we can do, what we have achieved by now is log base BA is equal to 1 over x minus 1. For achieving log base BAB, we are supposed to have one more B in the scene or one more 1 in the scene. For that, what we do, adding 1 on both sides. If we add 1 on both sides, what we can do, 1 plus log base BA is equal to 1 plus 1 over x minus 1. Why we have done this addition? Because in place of this one, we'll write what? Log base BB. Because base and number are same, so it is always 1. Why we have written this log base BB here? So that by having the same base B, we can operate them together and we can actually make log B base BAB. And on the right hand side, obviously I have 1 plus x minus 1. So if I take the LCM, it is going to be always x minus 1 plus 1, that is nothing but x over n minus 1. Now I can combine the left hand side using my property log m plus log n is log mn. If I do that, my left hand side becomes log base b m plus n is mn, so it is going to be ab is equal to x over x minus 1, and that's what we were looking for. Log base b ab's value in the question, and it has come out to be x over x minus 1, and this particular answer is available in option number a, and is the right answer. Now, find the value of 2 log 11 minus 3 log 17 plus log 4913 divided by 1 to 1. So clearly we cannot do anything about log 11, cannot do anything about log 17, but yes, we can little bit try to simplify this expression on the third term available. If we do that, what we're going to get, it's going to be 2 log 11 is as it is, minus 3 log 17 is again as it is. The next sum that we have is log 4913 divided by 121. So if you manipulate and try to open up the 4913 and factorize, you will come to know that 4913 is nothing but 17's cube only. We can find out that using the prime factorization. Okay. Now, if you see the another number 121, so 121 is nothing but the 11 square only. Okay, because these numbers have to have in the 17's power or 11's power only, then only they can be operated together, because there is no log value given. So by trial and error, you can easily find out that 4913 is the 17th cube and 121 is the 11th square. So I can clearly write here 17 cube and 11 square in place of both the numbers. Now, what else can be done? It's still 2 log 11 minus still 3 log 17. Now I can use my properties. What are those properties? Log m by n is always log m minus log n. So I can simply write log 3 log 17 for log 17 to the power 3 minus 2 log 11 for log 11 square. Okay. This is how I can write. If you see this expression, things are getting cut. This 2 log 11 getting cut by this, and this 3 log 17 is getting cut by this. So it ultimately becoming equal to 0. So that should be the right answer. 0 is the right answer available in option number C. The value of log base 2, log base 2, log base 3, log base 3, 27 cube. So in this type of questions, we are supposed to solve the questions from right hand side. So the right hand side is 27 cube. If at all we can make the base and number same in each step, then that particular log term is eliminated one by one from the right hand side. Okay. From the right hand side, if we try to make the base and number same, the log terms can be eliminated one by one. So let us just try to do it. Let us write log base 2 as it is, log base 2 again as it is, then we have log base 3 as it is, then we have the final log base 3, and in place of 27 cube, what I can write 3 cube, and there is one more 3 over there. So this is how the 27 cube has been manipulated. How will this look like? This look like log base 2, log base 2, then it will be log base 3. And how much this will become? See, log m to the power n is nothing but n log m. So this power 3 will come down here. So we'll left out with, and see, 3 to the power 3 to the power 3. So it's actually 3 into 3, that is nothing but 9. So this is not 3 that is coming back here. It is the 9 that will come back here. So it's going to be 9 multiplied by log base 33, that's what you will be left out with. Okay, 9 has come back, and log base 33, that's what is left out with. Now log base 33 is always going to be 1, so one log term will be eliminated. Now you will be left out with log base 2, log base 2, log base 3, 9. Okay, now this 9 can again be manipulated as log base 2, log base 2, and this 9 can be written as 3 square. Why we written like that? So that again the base and number can be made together equal. So the next thing is log base 2, log base 2, and see this 2 will again go back in the power using the property log m to the power n is n log m. So this will become like 2 log base 3 3, and this log base 3 3 will again become what? It will again become 1, because the base and number are same. So the next step you will have log base 2, log base 2, and this will be 2 into 1, so this is only 2. Now in this step, if you see log base 2 2, that will again become 1, so you are left out with log base 2 into 1, and once log to any base is always 0, so the final answer of this question is 0. Okay, the right answer becomes what? Is 0, which is available in option number A, and is the right answer. Now, log base 10 10 1 degree plus log base 10 10 10 2 degree plus so on, log base 10 10 89 degrees is equal to what? Okay, so obviously we'll have to solve this by some mathematical form, because all the options are having numerical forms. Clearly there has to be a numerical answer of that. So we'll have to use some trigonometry tricks. So let us try to find out how we can write log 1089. Okay, or rather how we can write 1089. 1089 can be written as 10, rather it can be written as 1090 minus 1. Okay, and which is nothing but cot 1. Okay, because 1090 minus theta is always cos theta, that is a trigonometrical rule. 1090 minus theta is always cot theta. So that's why 1089 has been written as 1090 minus 1, and 1090 minus 1 is nothing but cot 1 degree, because of 10 minus 90 minus theta is cot theta, so it is cot 1 degree. 1089 can be replaced by cot 1 degree, but cot 1 can again be written as minus of log. See, cot can be written as cot of this cot 1. How we can write this cot 1 is nothing but cot 1 degree can also be written as 10 minus of 10 1 degree, because cot theta is equal to minus of 10 theta. That is one more rule, or rather 10 theta is equal to minus of cot theta. That is also one rule. So what we can write for cot 1 degree, it can be written as minus of 10 1 degree. So ultimately, this whole log 1089 can be finally replaced as minus of log 10 1 degree. Okay. Similarly, if you have the next term, that is log base 10, the previous term would have been 1089 degree. Okay. So 89 degree is done. So the next previous term would have been log base 10 88 degree. Okay, so that would have been written like, in the first step, that would have been written like log base 10 90 minus 2 degree. That would be have written like 90 minus 2 degree. Okay, 90 minus 2 degree, that would have been written like log cot 2 degree, and that would have been written like minus 10 2 degree. So this log 88 degree would have been replaced by minus 10 2 degree, like that. So if you go on seeing like that only, then most of the terms are replaced except for the first term. Okay, all the term would have been replaced, and you would have achieved things like this: log 10 1 degree, this would not have been replaced. Okay, then the next term would have been plus log 10 2 degree, and similarly if you go in the middle, there would have been somewhere log 10 44 degree, then there would have been plus log 10 45 degree, and then you would have starting the things with negative sign. The negative sign of the next term would have been 10 44 degree. Next negative times term should have been 10 43 degree, 42 degree, 41 degree. So it will keep on continuing till 10 minus of 10 2 degree. So all these terms would have get started cancelling. Okay, and the last term that you would have, second last term that you would have left out would have been minus of, not plus, minus of log 10 2 degree, and the last term would have been minus of log 10 1 degree. So clearly you can see each and every term is getting cancelled, okay, by minus sign, minus sign, minus sign always, except for the term log 10 1 degree, which is nothing but log 10 45. Okay, which is nothing but log 10 45, which is exactly in the middle. That is not cancelled, because we can start cancelling till 1045, then it again start reducing. So this middle term log 1045 is not cancelled. Now log 1045 is nothing but log of 1, and log of 1 is always 0. So ultimate answer of this question is also 0, which is available in option number and becomes the right answer for us. Now, a to the power x equal to b to the power y, then find out the value. So then we have to check which particular expression hold the same expression's interest. Okay, let us just see. The first thing that is given is a to the power x equal to b to the power y. Now, as the options are given in the log form, so let us take the log. If you take the log, what do you achieve? Log of a to the power x is equal to log of b to the power y. This is what you achieve. Now, if you take the base, the power at the back, x log a is equal to y log b, which property has been used here? If you check, log m to the power n is nothing but n log m. This is what is the property that has been used. Now, this is what you achieve: x log a is equal to y log b. Okay. Now, if you see it carefully, what's going to happen? Log a by log b is nothing but y by x. Log a by b is nothing but y by x. That is what is the mathematical form, and it is simply available in option number B. So that is the right answer. Log a by b is equal to y by x becomes the right answer for us. Now, what is the number of digits in the numeral form of a to the power 17 when log base 10 2 value is 0.3010? So, to find out how many digits are there in a to the power 17 and using base 10 2, that is log 2 value, we are obviously supposed to manipulate a to the power 17 in the power of 2. How we can do that? That can be done easily. A to the power 17 can be written as 2 cube to the power 70, which is nothing but 2 to the power 17 3 is 51. So ultimately a to the power 17 is nothing but 2 to the power 15. So we are supposed 51. So we are supposed to find out the number of digits in 2 to the power 51. For that we have a method. What is that method? Let x equal to 2 to the power 51. Taking log on the both sides, so it becomes log x is equal to 2 to the log of 2 to the power 51. We can use a property here which is 51 log 2. Which property has been used here? Log m to the power n is n log m. That is the property used here. Okay. Now log 2 value is already given to us in the expression itself, 0.3010. Let us do that. So it's going to be 51 into 0.3010. If you solve this further, this comes out to be 15.3510. Now, we are supposed to find out number of digits. For that, we just need the left side number of the decimal point, that is 15. Okay. And what do we do with that 15? We add 1 to it, which gives us 16. So total number of digits in 8 to power 16 is nothing but 16 itself. What did we do? Whatever is the number present on the left hand side of the decimal point, that is 15, and we added 1 to it. Always this has to be done only. Whatever is the number present on the left hand side, just add 1 to it, and whatever number appears, that is the number of digits in the final answer. So that is 16. Option C is right. Okay. Question number 37. They say log x over log 5 is equal to log 36 by log 6 is equal to log 64 log by y. What are the values of x and y? So we are supposed to find out the x and y. So let us take it one by one. First of all, we have log x by log 5 is equal to log 36 by log x. So let us try to solve this part first, and obviously this will start giving us the x value. So if you see this log 36 by 6, how can this be written as? Log 36 by 6 can be written as, log 36 can be written as 6 square over log 6 is as it is. Now, what is this 6 square can be written as? This is written as 2 log 6 over log 6. How we have done that? Log 6 square can be written as, using the property log m to the power n is nothing but n log m. So this power has gone back. So we have received 2 log 6, and this log 6 and log 6 get cancelled. So ultimately you are left out with value 2. So clearly we can write log x by log 5 is nothing but 2. Now we are supposed to find out the x value. So what we can do, log x is equal to 2 log 5. It has gone in the multiplicative form. Now this 2 can be risen up. Okay, so it can be written as log of 5 square using the same property. N log m is nothing but log m to the power n. So power can go further also. That's what has happened here. So clearly we are getting the indication log x is equal to log of 25. So these two logs numbers has to be same. So clearly x is equal to 25. So first value has come, x value has come out to be 25. Now in the same fashion, we are supposed to find out the y value. The expression given for y is log 64 by log y. So log 64 by log y, that will also be equal to the same log 36 by 6, log 36 by log 6, which came out for us as 2, in the previous calculation itself. So in this also we can take it as 2. Now what we can do with that? Now clearly log 64 is equal to 2 log y, again the same situation. Now what we can do with this, log 64 is becoming equal to 2 log y. Okay, we can manipulate 64 also. Okay, log 64 is equal to power y. How can we write log 64? Log 64 can be written as 2 to the power 6, because 2 to the 64 is nothing but 2 to the power 6 is equal to Log y square, this can be written as log of y square. The same property has been used. The power can go up front. Okay, now both the logs are same, so clearly y square can be 2 to the power 6. So y square is coming out to be 64. So y value is nothing but under root of 64, that is nothing but 8. So the x value has come out to be 25 for us, and the y value that is coming out to be is 8. Which option is containing that? Is option number B, 25 and 8, and becomes the right answer for us. Now the next question is, for what value of x is log base 10 all this triple line plus under root of x square minus 3x plus 3 is equal to 3. So this is what we are supposed to solve. So clearly there is no direct property that I can use here. So I need to solve them mathematically. Okay. One thing that can be done is log base a b is equal to c. Whenever the three numbers are connected in the log form like that, then the mathematical connection between them is a to the power c is equal to b. This is what is the mathematical connection. Okay, a to the power c is equal to b, that is the mathematical connection. So clearly when you have things like this, okay, so what is the mathematical connection? 10 cube is equal to the expression that is given to it is 999 plus under root of x cube x square minus 3x plus 3. Okay, so what we can write, under root of x square minus 3x plus 3 is equal to 999, 1000 minus 999, that is nothing but 1. Squaring both sides, we achieve x square minus 3x plus 3 is equal to 1. If we solve this further, this can be x square minus 3x plus 3 minus 1 equal to 0, which gives us x square minus 3x plus 2 equal to 0. If we solve this equation further, okay, so we can easily factorize it. So the factors are x minus 1 and x minus 2. These are the factors equal to 0. So the values are x equal to 1 and x equal to 2. These are the two values that we achieve. Okay, so which option is containing both the values? Option number D, 1 and 2, and that becomes the right answer for us. Now find the value of log. The numerator is fourth root of a to the power 5. Denominator is fifth root of b to the power 4 into under root of c. That one is the expression. Okay, let us just try to solve this. Okay, we can obviously write these under roots and the fourth and fifth root in the power as 1 upon 4 and 1 upon 5 both. So this particular expression can be written as log of a to the power 5 by 4 divided by b to the power 4 by 5 into c to the power 1 by 2. This is how it can be written like that. Okay, now if we try to use that property, what is it going to be? Log of a to the power 5 by 4 minus log of b to the power 4 by 5 minus log of c to the power 1 by 2. How this has happened? Because log m over log m over n is always log m minus log n. Whatever in the denominator comes back in the subtraction form, and whatever is in the product form, log m into n is always log m plus log n. So that was has been used here. The in the denominator you had a product term, so that has come in plus form, but ultimately there has to be a minus form outside. Okay, because the whole thing is in denominator form also. So this is what you finally achieve after that. Okay, but we have to match it with the options also, and there's no option in which we are getting all the terms as minus, so we'll have to manipulate this further. Okay, how we can write this as? Now this first term can be written as 5 by 4 log a. The property used is log m to the power n is n log m minus log b to the power b 4 by 5. So let's take the minus outside common. So we are left out with 4 by 5 log b. Property used is log m to the power n is n log m plus log c to the power 1 by 2. So property used is 1 by 2 log c. The same property has been used multiple times, and this particular option is available in the options. Okay, this particular answer is expression is available in the option, and which option this is carrying it is exactly option number D. So that is the right answer, which is available in the option number D. Now log 27's value is 1.431, then find the value of log 9. Okay, so clearly there is no direct situation that can be directly applied. So obviously log 27 value is given and we have to find out log 9. So basic connection between 27 and 9 is both can be manipulated in the power of 3. So let us just start with the thing given to us. Log 27 is equal to 1.431. That's what has been given. So this log 27 can be manipulated in the form of 3. So it can be written as 3 cube, okay, is equal to 1.431. Okay, we can use a property log m to the power n is n log m. So this 3 can go back. So we can ultimately achieve 3 log 3 is equal to 1.431. What property has been used? Log m to the power n is n log m. This is the property that has been used here. So this is what is you achieve 3 log 3 is equal to 1.431. Obviously this 3 can go in divide form, so you can achieve log 3 is equal to 1.431 divided by 3, okay, which is nothing but 0.477. So log 3 value is coming out to be 0.477. This is what is the first thing that you achieve. Now, what we are supposed to find out? We are supposed to find out log 9. Now, we need to manipulate log 9 again in the form of log 3 because we have got the value of log 3. So, log 9 can be written as log of 3 square. Okay. Again, we can use the property log m to the power n is n log m, the same property that is used here. Okay. If we do that, this 2 will go back. So, it becomes like 2 log 3. Okay, that's what it will become. Now we can replace a log 3's value here. If you do that, it's going to be 2 into 0.477. That is nothing but 0.954. Okay, so that should be the right answer, 0.954. Let us find out where it is available. It is available in option number B and should be the right answer for us.